So as I was saying, we have the traffic signal that's rotating through its phases of red, green, yellow. But what's new and different is the fact that we have this vehicle which automatically is able to have knowledge of that transition happening. So you will see this vehicle being in synchrony with the traffic signal over there. So it's in green, it's in yellow, and then it's going to go to red. Furthermore, you'll see the number of seconds that the signal phase will be active, and the car is aware of that. So imagine a situation where the driver is not aware of the signal actually changing. Your car is already aware of it. So the car has that knowledge irrespective of whether the driver has that knowledge. And that information is able to be communicated to the car quickly because of that transport optimization we just spoke about, reliably because of that seamless connectivity that we just spoke about, and with a high degree of security, especially in scenarios where you are dealing with roadside infrastructure to vehicle communications. Security is paramount. Why? Because you want to make sure that the source that you're receiving the information from is an authentic source, and that the information is not tampered with. You can certainly imagine scenarios where somebody, a hacker or a malicious individual can go in and put false signals in. It would cause chaos on the city streets. So Cisco is able to provide a superior level of security and connectivity to ensure that this kind of communications is highly reliable. So that is the car to roadside infrastructure communications. Next, what I'd like to do is demonstrate car to car communications. And for this, I need a volunteer. Who's going to be my volunteer? I need somebody on this side. This is a simple volunteering. Okay. What's your name?
David.
Hi, David. Okay.
Hello.
This is easy. I just need you near the red light over there. Okay. Let's start. So what we're going to do, and I'll tell you what's going to happen before we start. We're going to start this first car is going to start running, and then we're going to ask David to suddenly hit the brake button. Not that that ever happens on the road. Nobody suddenly brakes on the road, right? So he's going to suddenly hit the brake button. This guy might be texting, might be taking pictures, might be on the next phone call. I want everybody here to see what happens on this iPad when David presses that button. Okay?
Right.
All right. Let's start the first car. There he's zooming down the highway. David, press the button. Hold it. No, hold it down. Hold it down. Hold it down. What's happening? What do you guys see? A stop signal. Let's turn that off. So it's a simple experiment. What it's showing is this car brakes suddenly, and the knowledge of that car braking suddenly is instantaneously transmitted to the cars around it. Immediately around it, the cars are notified, irrespective of the driver actually knowing himself. It happens at wire speed. And by becoming aware of that knowledge, what can happen? Higher level applications can take that data and either send a visual alert, an audio alert, or transmit it to the car infrastructure to trigger the slowing down of this car or applying brakes as appropriate, or maybe speeding it up, whatever is the appropriate. So you're able to get contextual information transmitted at wire speed to cars on the road. And that really makes for a safer and more reliable commuting experience. Okay? Any questions?